Hello everyone, welcome back. Let's welcome Jess to deliver a talk on Productionize research-oriented code by Python. Over to you, Jess.
Hello everyone, I'm Jesse. I have been in education and technology industry for several years. In this industry, I have tackled the issues between data science and engineering in AI/ML projects. So based on my experiences, I'm going to talk about the process to productionize research-oriented code by Python. So let me share background at the first. Python engineers assigned to AI/ML project and frequently face a research-oriented code. So understanding the process to productionize research-oriented code can help make AI/ML projects work more smoothly. The target audience might be Python engineers who is involved with R&D, data scientists, product owners in AI/ML projects, or data engineers. So 3 years ago, I made a 5-minute lightning talk about this topic in PyCon US 2019. So this was my first talk on the stage in my life. So during the 3 years, I have made the talks about Python and data science topics around the world and published a book about them. Then I came back to PyCon US today. So this talk is aggregated based on my 3 years experiences of the project with data scientists, and what I wrote in the book, and the past talks in PyCon. So I abstracted the 4 steps to transform research-oriented code into products. Understand the code, modularize the code, refactor them, and then make them product. So that's it. It's very simple. I will explain each step one by one, much deeper. So the code samples in the 4 steps are written based on the item response theory, also known as a 2-parameter logistic regression, which is a classic statistical model mainly used in educational psychology. But this model is normally used for predicting how many students can get correct answers based on the features of questions. So this talk, I use the code based on this statistical model, but the model is not the main topic in this talk, so I will not talk about the model itself. So let's look at the first step. The first step is to understand the research-oriented code. So in general, a research-oriented code is implemented for figuring out something new and summarize the results into paper. So research-oriented code AI/ML project is a code written mainly by data scientists or researchers for figuring out new knowledge. So finding something new is the highest priority when writing the code. This is a common life cycle to write paper with code. Only one person starts to collect data, pre-process it, train or calculate the data, and then see what the results are telling you. If the results present new knowledge, write paper with it and publish. So this code is the pre-processing code written during this process. This code seems to be long function and used for loop, but it tends to be visually traceable from the top to the bottom. Also, it can be easily and quickly written. It's not clean code, but it's enough to quickly get results. So this is the example of calculation code. This code uses DotaPen and use data frame. It easily handles the input data, and it traces output data with data frame. So on the other hand, what is the code in production level? So according to this thesis about how we can evaluate ML production system based on the rubric, the thesis scores ML system from 0 to 12 plus. So 0 points seems to be more like research-oriented code before transformation. The ML system scoring from 7 to 12 plus is a product a few years after deployed on the production environment. So the target goal of the 4 steps I suggested in this talk is a product scoring from 5 to 6. That means reasonably tested, but it's possible that more of those tests and procedures may be automated. So the product quality improved through these kinds of the development cycle. I have had experiences to be only one Python engineer in a company for a few years, but generally engineers develop web application with a team. So they make architecture, implement features, test and review, and release product. So they receive feedback all the time unless they develop very perfect product with no bugs. So they need to keep repeating, release and fix the product. So this means that production code needs high maintainability, scalability, and processing speed. This is an example of both previous code I refactored in Pythonic way. This code seems to be shorter than previous code, and there are list comprehension and set comprehension. There are 2 simple functions at the bottom. This code can build the model in a faster and simpler way. So I identified 3 differences between research-oriented code and production code. There are different scopes, different characteristics of coding style, and different objective coding style. So researchers focus more on writing preprocessing code and ML code, calculation code. On the other hand, engineers have responsibility to write whole part of the code in production level. The research-oriented code seems to be easily handled and visually traceable. And on the other hand, production code need to be concerned about high calculation speed, high readability, and they should be testable and modular. This is because the researchers focus more on finding the most efficient and suitable machine learning model or calculation code. And on the other hand, engineers have responsibility to make the code work on the server correctly and reliably. So what are Python engineers supposed to do for research-oriented code at first? So what is the first thing to do? So deep dive in the code. So read the code before write it. The left picture is a Jupyter notebook, features long lines. I used to frequently receive the code. Okay. On the Jupyter notebook from the okay, I will continue. Yeah. So after you receive the research-oriented code, take notes for deep dive in the code as if you were scribbling. So there are 3 strategies to take notes. Prepare for modularization. Just quickly take notes while reading the research-oriented code. So first one is to write comment by using sharp. Second is add to the comments. These 2 are things everyone already does. The third one, the third is mob documentation. What's that? So mob documentation is very useful to efficiently understand the code with the team. So if you're using VS Code, install a live share extension of VS Code, which enable to share code and edit together. So after mob documentation, the team members who join this mob can be on the same page and do not need to extra wiki and documents about this code. So also, if you do with junior when you hire, it can be good for onboarding. So this is an example of part of page of research-oriented code with comments. So while reading the code, add what you understood from the code with comments and to-do memo. So this should be done for understanding more about the code, not only for remembering the code and to-do. So the conscious and attitude about understanding more about the code and getting more familiar with the code is going to make different in the way to take notes on the code and easily lead to the next step. So next thing to do is to modularize the code by using levels. Research-oriented code has 3 types of scopes, such as the code to prepare, pre-post process, and calculate data. So based on the comments you wrote in previous step, categorize the code into preparation code, pre-post processing code, and calculation code. So after grouping each code with levels, we can break them into functions and make them testable. So while grouping each code, you would find duplicated codes, user lines or libraries, or small bugs. You can fix them in this step. So then we can get modularization outcome like the table. So we could get modules for each from one page of research-oriented code. We could get preparation.py, which is functions to access database, execute query, and load input data. We also could get preprocessing.py, which has functions to replace categorical data with discrete numbers, filter input data, and rename columns. So finally, we get prediction.py, which has functions to calculate logistic regression and output results. So now, as a result of that, so the research-oriented code became loosely coupled. So you can make directory structure mapping each module. This is one of the directory structure examples of API developed with Flask. I found that this kind of directory structure is very simple and easy to work with. The directory structure on the left box has API directory and model directory and main root directory. The data-init.py module located in API directory has a routing list. Each logic for each endpoint is implemented in each module located in URL directory. So if you are working in a small team from 1 to 3 members and implement new modules, you can just add it to a new endpoint in URL directory. If the number of team members increase, you can split each module into each version and work together, staying loosely coupled between modules. So I wrote the directory on the slide in the case of API with Flask, and Fast API also can have similar directory structure, but generally the way of mapping relies on the manner of each framework and what you want to develop. So now we reach to the step to refactor, preparation code and pre-processing code. So before starting to refactor the code, we should write a test code roughly at the doc string such as restructured text style, NumPy style, and Google style, and execute code formatter such as black or AutoPep 8, and check if code correctly work by using PyTest, and check the consistency of coding style by using Flake 8. And other than that, type annotation could also be one of the options as code documentation if all team members are familiar with the grammar of type hinting. So you can narrow down more about requirements of each code through these three processes. Then we can finally start to refactor the code. Now, which part of the code should we refactor? Just focus on preparation code and pre-post processing code. In general, ML library and mathematical library are used in prediction module, so the code does not have many lines to write and refactor. The optimization of CPU bounding processing can be done later after we could make sure if the code can work correctly on the server. Also, we have chances to figure out if the prediction is not validated yet through refactoring here. So we are trying to refactor I/O. Preparation.py has a group of codes to access to database or object storage by using query and client library. So let me share a few examples I frequently have faced and how I simplify them. In exploratory analysis phase or data wrangling, data scientists are not sure of which data is specifically useful. So if you receive the first query with a star, so narrow down the data to extract from database, and it could be much faster and lower cost like the second code. In accessing the object storage, sometimes you might make effort to write many lines just for loading CSV file by using client libraries. So one of my suggestions is that you wrap the code and make it simpler, then it can be reusable and cost effective. That's because this kind of code is the same code even though anyone write. Everyone in AI/ML projects such as data engineers, Python engineers, and data scientists write a similar code. Not only your team members, but also the members in the other team might be writing the same code just for loading the data. So also, it might be chances for Python engineers to make a big impact internally. So next, let's look at the preprocessing.py. The libraries for analysis use and development use are different. A group of the code to pre-process or post-process the data tend to include various kinds of libraries, and data type is also mixed. As one of the common cases, there are three ways to post-process the data, like pandas, Python only, and the SQL query. The common operations are filtering, replace, deduplicate, and there is the data for each three way. So most of research-oriented code needs pandas code or SQL query or both. So these three ways have different features. The code with pandas is iterative to fix and write the code. Python-only code can be testable, and the SQL query has high processing performance and simple grammar. So it depends on architectures and the project scale, but the first things to think about is whether pandas and the SQL query is necessary or not, and refactor them into Python-only code for making them more testable. If the data using for calculation is already specific and extracted in preparation.py, we don't need to write many pre-processing codes by Python. So last step is to make them product, which is API. So what products can be generated from research-oriented code? So output is not paper, it's a product, which means the code working on the server, and users can access to it. But there are several kinds of product appearances, so quickly let me narrow down the scope about the products in this talk. So the products can be web application or web API. So this is drawing of the flowchart of transformation from research-oriented code into products. So in this slide, POC is more like products, and analysis scripts are mainly written for business reports. So when having a look at general overview of data-oriented projects, both type of the code can also exist in this flow, but this talk focuses on research-oriented code. So the 4 transformation steps could be mapped on the flow chart like this slide. There are 4 patterns of transformation from research-oriented code into products. One is the model or the calculation code extracted from the research-oriented code is directly integrated into web application. The second is that we can implement API based on the research-oriented code. Third is that when we use ready-made API or third-party API, we normally integrate them into web application for using them. Last one is that when the model or the calculation code is already integrated into web application, we extract this part of the code and make it API for public use. So this talk focuses on developing web API. So in order to transform our research-oriented code into web API, we have to implement how to route request and check request, check error, and the routing points, which are endpoints. So let me share the tips to implement request routing and URL. And there is a table of input data on the left side on this slide, which is used for 2 parameters logistic regression. On the right side, there is a table of output data calculated by the model. The input data is about whether students answer each question correctly or not. Their item name, which is the name of question, item ID, how difficult each question is, subject names, exam name, and correction, which is binary data. On the other hand, output data is about probabilities to answer questions correctly. So the role of this API is to get probabilities so we can directly label probabilities as the endpoint name. So based on best practices, our function name should be verb or verb plus noun. So the role of this function is to calculate the results or get probabilities so we can label calculate result or get props as a function name. So understanding what data is input and output, which means understanding what data the code calculates and makes, is considerably important step to make API. Next is implementation of request parameter check. My suggestion is to implement request parameter check with JSON schema. This request call command has student name and student grade as parameters. This JSON file is sample JSON schema. In this file, you can define what data should be checked and how the data should be checked. So this make name grade.json file is defining the data type of student name as string, and it must be included as request parameters. And the data type of student grade is also defined as string, and it must be included as true. And the maximum length of character is limited to 120, and the minimum length is 1 character. So in this example, request parameters are not allowed to be empty. So based on the JSON schema, the JSON validate.py validates the request parameters. The first validate JSON function checks whether the JSON schema exists or not. The second validate schema function checks whether the request parameters are correct or not based on JSON schema defined in previous slides. In order to execute these functions, write function name as a syntax sugar under the endpoint. The code with JSON schema seems to be complicated, but most of the code are like this on this slide, so you can refer to this code. I will upload this slide on my Twitter as well. So last implementation is error check. So before implementing the code, we need to think if processing should be stopped or continue for each code. So whether the processing is stopped or not depends on service specification. For example, if you implement recommendation system, sometimes you do not want to stop services and continue recommendation, even when the preparation code failed to load certain data. So this is an example of error handler with Flask. If you stop processing, you can use a board function and detect error. If you do not want to stop processing, you can just return the result with JSONify. So it's very easy to implement it, but it's more difficult to decide which part of the code processing should be stopped or not. So I suggest to talk with product manager or QA team about the service specification before starting to implement error check. Okay, so let me quickly summarize 4-step transformation from research-oriented code into products. First thing is to understand the characteristics of the code and figure out how it is working by taking notes. Second, modularize the code based on the code documentation by labeling the code as preparation, pre-processing, and calculation. Thirdly, refactor the preparation code by simplifying I/O and the pre-processing code by changing the coding style. So lastly, make them product, which is an API composed of request routing, request parameter check, and error check. So after deploy the product, we need to optimize the speed and the stability by doing load test. So there are useful load test tools such as Locust and Vegeta. Locust is a Python-based load test tool which can make it possible to manage load test scenario by Python code and monitor the loading on the server by GUI. The Vegeta is Golang-based HTTP load test tool. It can be used both as command line utility and library. If you are looking for the light load test tool, Vegeta could be one of the options. And you can do Vegeta attack on your code. So by using those kind of load test tools, if we figure out the performance is not good enough, we do parameter tuning of web server and the application server, and think about asynchronous or synchronous. Even if it is not improved, we think about architecture, infrastructure, or refactoring the code with different languages. So just in case again, 4-step transformation from research-oriented code into product is very simple. Understand the code, modularize the code, refactor them, and then make them product. After you deploy the code, check the performance. Thank you.